A task fails, and the first suggestion is often split it into more agents. Add a planner, a researcher, a writer, a critic, and maybe a manager agent to coordinate the rest. That can be the right move. It can also turn one understandable failure into 5 model calls, several handoffs, duplicated context, retries, timeouts, and a trace nobody wants to read. This lesson is the architecture decision before the architecture diagram. When should the answer be deterministic software? When is one agent with tools enough? And when do multiple agents create a real advantage? We will build a small decision function, run it against contrasting workloads, and keep one rule in view. Choose the simplest architecture that can meet the requirement. Start with 3 choices, not with a framework name. A deterministic workflow is ordinary software. Rules, transformations, retrees, validations, and fixed decisions live here. If stable code can solve the task, an agent usually adds cost and non-determinism without adding value. A single agent with tools is the default agentic shape. One model-driven loop owns the conversation, selects tools, keeps state, and decides what to do next. A multi-agent system has multiple model-driven loops. Separate agents can receive goals, use their own context, choose actions, and decide when their assigned work is complete. The key is not how many prompt templates you have. The key is how many independent control loops you are willing to operate, trace, and test. The public lesson turns this decision into data. The architecture enum names the 3 outcomes: deterministic workflow, single agent with tools, and multi-agent system. Then Workload Signals captures the evidence, stable rules, need for model judgment, independent branches, distinct contexts, separate tools or permissions. Independent review. It also captures the reasons not to split, shared context, tight dependencies, and strict latency. Architecture decision carries the result, the reasons, the risks, and the next experiments. That last part matters. This is not a magic scoring formula. It is a reviewable decision record. If you cannot fill in the signals clearly, you probably do not understand the workload well enough to justify more agents yet. The first branch is the easiest to skip and the most important to respect. Can stable rules cover the task? A nightly invoice export does not need a model to improvise. Query approved records. Format the file. Upload it. Retry bounded failures. Validate the result. That is software engineering, not agent design. In the code, if stable rules cover the task and model judgment is not required, the recommendation is deterministic workflow. This is not a less advanced answer. It is the cleanest boundary. Use agents where judgment over ambiguous, changing, or unstructured input actually matters. Do not use them to replace rules that are already known. Now suppose the task does need model judgment. Start with one agent and clear tools. A support assistant might search policy, inspect an order, create a ticket, or draft a response. One control loop owns the state and the next action. That makes evaluation, security, and debugging easier. One agent does not mean one giant prompt with every document and every tool loaded at once. You can load context on demand. You can hide irrelevant tools. You can improve tool names and schemas. You can route deterministic steps around the agent. Multiple agents become candidates only after you can name the limitation that one agent is failing to handle. The strongest multi-agent signals are about useful separation. Independent branches are the cleanest case. 4 market researchers can work at the same time. Then a coordinator can synthesize their findings. If the branches are truly independent, separate agents can improve coverage or elapse time. Distinct contexts are another signal. Legal, security, and finance may need different documents, tools, and instructions. Separate specialists can keep irrelevant contexts out of the way. Separate permissions or ownership can also matter. Different teams may own different tools or deployment cycles. Independent review is the last signal here. A producer creates an artifact. A reviewer checks it against evidence and a rubric. That is stronger than asking the same loop to reassure itself. The decision function requires more than one benefit. It also asks whether the task value supports the extra work and whether coordination costs are limited. This is where many designs should stay simple. If every branch needs the same context, agents will copy and reconcile the same information. If the steps are tightly coupled, parallelism disappears. If the latency budget is strict, extra handoffs can make the system worse. When the evidence is not strong enough, the code recommends a single agent. It also returns experiments. Improve tool descriptions, load context on demand, and measure the baseline before adding agents. That is the habit to build. Do not argue from agent count. Argue from measurable limits and measurable improvements. The demo runs 3 scenarios. Nightly invoice export chooses deterministic workflow because stable rules cover the task and model judgment is not required. Support assistant with tools chooses one agent. It needs judgment, but shared context and latency pressure make extra handoffs unattractive. Cross-market diligence chooses multi-agent system. It has 4 independent branches, distinct contexts, independent review, and enough task value to justify the extra operation. The exact thresholds are policy. The durable lesson is the shape of the decision. Start simple, name the evidence, name the costs, and test the behavior you claim the architecture needs. Use this as the interview answer. I use a multi-agent system only when separate model-driven control loops create a concrete advantage. First, I check whether deterministic software can solve the task. If model judgment is useful, I start with one agent and tools because ownership, state, tracing, and evaluation are simpler. Then I look for evidence that justifies splitting control. Independent parallel branches, distinct context windows, separate tools or permissions, or an independent reviewer with evidence and a rubric. I also check the coordination cost. If agents share most context, depend tightly on each other, or violate latency and cost limits, I keep the design simpler. The strong answer is not add more agents. The strong answer is measure the single agent baseline, name the limitation, and add agents only when the split improves the system enough to justify the handoffs.